Good morning to all of you. In today's class, we will start the operational amplifier and oscillators circuit. So, good morning to all the mechanical engineering students. So, my name is P. Srinivasulu, EC Department, Associate Assistant Professor. And in today's class, we will start the part B of Basic Electrical and Electronics Engineering. In the part B, I will teach you the third unit, that is oscillators and operational amplifiers. So, this is a part of electronics subject, electronic devices and circuits. And in this unit, we are going to discuss what is an oscillator and what are the different types of oscillators are present. And after that, what is an operational amplifier, that is op-amp. And what are the different types of operational amplifiers and applications of operational amplifiers. This is a very simple subject, and this unit especially very simple, and you can score more marks in this just by spending 1 hour or 1.5 hour time on this. Okay, so now we'll directly go to the subject. We'll see what are the different topics we have, and also we'll start directly discussing about the subject. Okay, now first this is a unit 3, oscillators and operational amplifiers. Op-amp means operational amplifier. Okay, so op-amp is operational amplifier. Now, so first, as a first part, we will see what is an oscillator. An oscillator is an electronic circuit which generates an AC output waveform without using any AC input signal. So therefore, here these two are important parameters: AC output and AC input. So oscillator is an electronic circuit. Circuit is nothing but interconnection of components. So electronic circuit which generates an AC output waveform without using any input signal. We need not to give any input signal to an oscillator in order to produce the sustained oscillations, especially that is an oscillator. Okay, so I think you are clear about what is an oscillator. Oscillator is an electronic circuit which generates AC output waveform without using any AC input signal, or for that matter any input signal. Okay, now so we will see what are the different types of oscillators are present. Okay, sinusoidal oscillators, non-sinusoidal oscillators. Okay, sinusoidal oscillators means the oscillators in which the output waveform is in the form of sinusoidal in nature. Okay, like so sinusoidal means actually sin omega t, cos omega t. So these are the examples of the sinusoidal signals. So therefore, if the output of an oscillator is sinusoidal signal, then we say that it is a sinusoidal oscillator. It's simple to remember. So if the oscillator is producing sinusoidal oscillations means just you can remember like this. Oscillations are, so these are sinusoidal oscillations. Okay. So therefore, if the output of the oscillator circuit, suppose if you have some oscillator circuit, that oscillator circuit is producing sinusoidal output, sinusoidal oscillations, then we say that it is a sinusoidal oscillator. Example for sinusoidal waveforms: sin omega t, cos omega t, like that. And non-sinusoidal oscillators are also there. They are simply you can understand from the previous one. So if the output of the oscillator is a non-sinusoidal waveform like square waveform, rectangular waveform, sawtooth waveform and triangular waveform, like this, any type of non-sinusoidal signals if we get in the output of the oscillator, then we say that they are non-sinusoidal oscillators. Okay, example, see, square wave means like this. If the waveform like this in the form of squares, we say that it is a non-sinusoidal oscillation. It is a square waveform. Then if you go for a sawtooth, so sawtooth waveform. So sawtooth waveform means it looks like this, right? It is like a tooth of a saw. Then we call it. That's why it is called as a sawtooth waveform. Okay. So therefore, like that, rectangular, triangular. So the shape can be anything. If the output of the oscillator is a non-sinusoidal in nature, then that type of oscillator is called a non-sinusoidal oscillator. So this is an example of a non-sinusoidal waveform. This is also an example of a non-sinusoidal waveform. This is a square wave. This is a sawtooth wave. Like that you can have a triangular also. So now what we have seen is what is an oscillator and what are the different types of oscillators, like general classification. So based on the output of the oscillator, we can classify the oscillator as a two basic main classification, that is a sinusoidal oscillators and non-sinusoidal oscillators. Okay, now furthermore we will go into the some other conditions, like so to get a sustained oscillations, the oscillator must satisfy some of the conditions. They are actually we call it as a Barkhausen criteria for oscillator operation. Okay, what is the Barkhausen criteria means? So the magnitude of the loop gain. So A beta. So A into beta, that the magnitude of A beta must be 1. So where A is the open loop gain of the system and B is the feedback factor. So mod A by A beta must be 1. So which is called magnitude condition, and angle of A beta must be 0 degrees or 360 degrees. If these two conditions are satisfied by an oscillator, then it produces a constant sustained oscillations in the output of the circuit. Okay, that is why we say that. So Barkhausen criteria means it is a criteria. It has to be satisfied by any oscillator circuit in order to produce a constant oscillations or sustained oscillations. Okay, now as the next one we will see components of an oscillator. What are the different types of components of an oscillator? Okay, now so there are mainly three important parts are there. They are like transistor amplifier, feedback circuit. You can observe here transistor amplifier, feedback circuit and oscillating circuit. Okay, now we will see a simple block diagram of this oscillator circuit, simply oscillator in the form of blocks. Okay, so that we can get from this. See here. So here you can observe, see everything. So transistor amplifier. This is transistor amplifier. Next one, it is a feedback circuit. Feedback circuit. Then this is a oscillating circuit. Oscillating circuit. Okay, now so we will see. So this is the basic block diagram of an oscillator circuit. Block diagram. A representation of an oscillator. Okay, like this. Now we will discuss about this block diagram of an oscillator. So first what happens is, so this transistor amplifier will take the input and it amplifies, it converts any supply. Actually we have to operate a device, we need some supply voltage. So using the supply voltage, what it will do is, whatever the input signal comes, that is amplified by this transistor amplifier. So about this transistor, and we already have studied in the first and second units. So therefore transistor amplifier amplifies the signal which comes at the input side. So this is the input of the transistor amplifier. Now see here what we are doing is, we are taking some part of the output signal and we are giving it to the feedback circuit. Okay, feedback means we take the part of the output signal and that part of the output signal is given as an input for the feedback circuit. And feedback circuit generally it contains RC elements and also RC and L elements. Okay, resistor, inductor, it can have resistor R, inductor L, capacitor, C components it can have. It can have resistor, inductor and capacitor components, and part of the output signal. Okay, this is generally sampling. It is called sampling, taking some part of the output signal, and after taking some part of the output signal, that is given as the input for the feedback circuit, and this feedback circuit takes that input signal and operates on the input, and it gives you the output signal. Now what happens is, this oscillating circuit will take the output of the feedback circuit, and it operates on that, and it will produce some oscillations here. You will get some oscillations at the output of this. And now once after getting this oscillation, these oscillations are supplied to the transistor amplifier, and transistor amplifier will have a sustained output oscillations like this. So this is the overall operation of a oscillator, any type of oscillator, maybe RC oscillator or LC oscillator. So it is general idea. Okay, transistor amplifier amplifies the input signal whichever comes to the input of the transistor amplifier, and after that we take the part of the output and give it to the feedback circuit, and feedback circuit so operates on the sampled signal. Okay, that part of the output signal, and so it modifies that and takes that part, and accordingly it gives the output, and at the output of that feedback circuit, that output will be taken and it is given to the oscillating circuit. Okay, so this oscillating circuit is responsible for producing oscillations, and those oscillations are given to the transistor amplifier. Then it amplifies the input signal based it amplifies the input signal given to the amplifier, and so therefore you will get a sustained oscillations here. Okay, sustained means constant amplitude and frequency. Sustained oscillations. Okay, so like this, so we can generally will have a different components of an oscillator and how it works in a general point of view. Okay,